India, as we all know, is going through a transformation of sorts. What we are going to see in this episode is the amount of money spent on engineering research and development globally. Companies across these 9 major sectors spent 1.5 trillion US dollars. A portion of this spend gets outsourced to India. How does all this relate to an engineer? India, as we all know, is going through a transformation of sorts. Our leaders are talking about Make in India, and we as consumers are looking to buy the best products from phones, smartwatches, electric vehicles, and much more. Our internet, homes, and almost all appliances we use are getting smarter and connected. While all of this is happening at one end, we have the other spectrum of reality. Mechanical, electrical, civil, and electronics engineers are not getting relevant job opportunities. They only seem to be getting employed for production, maintenance, repair, or low-level manufacturing jobs with the age-old 15 to 20,000 rupees salaries. In fact, this scenario for core engineering streams in India has been the same for the past few decades. And as a result, students have stopped considering these domains at all. This has resulted in a decrease in enrollments across core engineering streams. But here's the most confusing thing. At one end, the government and leaders, both business and political, are promoting India as the destination to engineer and manufacture new products. But at the other end, people are stuck with low-paying jobs, or worse, no jobs. So what is the reality? I believe that there are a lot of opportunities in the Indian engineering spectrum, but most of us do not get exposed to it. That's why we haven't been able to build our talent and skills that Indian engineering sector needs. But this is just my opinion. How close is it to the actual reality? To find out, let's dive deep into the opportunities available in the Indian engineering spectrum. In this episode, we are analyzing nasscom and BCG's report on the global ER&D market. Before we dive into the specifics, let's first understand what ER&D is and where it stands today. What is ER&D? ER&D stands for Engineering, Research and Development. In this video, we will cover the different sectors, their area of focus, and how much they spend to develop current and future products. This is important because a portion of this spend gets outsourced to India through engineering service providers and global capability centers, or GCCs. Who are these engineering service providers? Well, companies such as Capit, L&T Technologies, Tata Elxsi, Tata Technologies, Persistent Systems, Hitachi Global Logic, Cyient, and many more. These companies focus on servicing clients across the world by delivering engineering R&D for global products in India. These are pure-play engineering R&D service companies. In fact, the largest engineering services arms are that of TCS, HCL, Capgemini, Infosys, and Accenture. Now that we saw engineering services companies, there are GCCs such as Bosch, Continental, Faurecia, Hella, Magna, Daimler, Renault Nissan Technology, Volvo, and many more. All these companies are set up in India and act as extended engineering arms of their parent companies from other countries. The increase in global engineering R&D spend results in increased demand for engineering services, resulting in an increased need for skilled engineers. And this is why in this video, we look at the engineering spend across the globe on different sectors. To make this clear, here's an example. In the automotive manufacturing industry alone, across the world, they spent $145 billion in 2022 pursuing research and development for their current and upcoming products. Similar to the automotive companies, there are other sectors that are big spenders in the engineering R&D domain. Some of them include aerospace and defense, consumer electronics, energy, oil and gas, healthcare and medical devices, industrial and construction sector, semiconductors, telecom, and software. Now that we know quite a bit about engineering R&D sector and its contributors, let us look at how much each sector spends. Globally, in 2020, companies across these 9 major sectors spent 1.5 trillion US dollars in engineering research and development. If you think this is a lot, actually it is not. 2020, being a pandemic year, accounted for one of the lowest expenses in the engineering R&D industry. However, after the pandemic, companies have accelerated their spends on ER&D, resulting in a CAGR of 8%. CAGR of 8% means that spending across the industry is growing at a rate of 8% year over year. Will this trend continue? Let's try and understand by splitting ER&D spending between 2020 and 2030 into 3 phases. Phase 1 is from 2020 to 2023. This is called the emergence from the uncertainty phase. As said before, the entire industry grew at a rate of 8% year over year in this phase. 2023 to 2027 is phase 2. And this is called the stabilization and transformation phase, where the industry is predicted to grow at 9% year over year. The ER&D spending in this phase will grow from 1.8 trillion USD per year to $2.5 trillion in 2027. 2027 to 2030 is phase 3. And this is called the sustained growth at scale phase. In this phase, the industry is predicted to grow at 10% year over year. This means the spending in the industry will grow from $2.5 trillion US dollars to almost $3.3 trillion US dollars. While the sector had a slow start in 2020 because of the COVID pandemic and uncertainty created by wars in Europe, the industry grew and is projected to grow even more. What is causing this growth? Especially after pandemic and in the middle of a macroeconomic slowdown across the world due to the Russia-Ukraine war. Well, there isn't one reason, but 3 major trends which cause this increase in spend. Number 1 is digital engineering. Companies are recognizing the improved outcomes for customers when traditional products are integrated with digital layers. And number 2 is climate and sustainability. Global climate targets and regulations for reducing the carbon footprint increase the demand for sustainable products and green energy. Number 3 is augmentation of AI, especially to perform generative engineering. Generative engineering, what is that? Well, companies are in the pursuit to conduct and integrate generative engineering powered by artificial intelligence. AI can automate and optimize designs across the likes of the automotive and aerospace industries, where automation and optimization can eventually increase efficiency and reduce the time and cost for development of new products. Now that we know about ER&D, how the spend in ER&D is growing, what are the different sectors in ER&D? Let's go in depth and understand which industries actually spend in ER&D and why, and how their spending could grow. The top 3 sectors contributing to the ER&D spend are automotive, software, and healthcare and medical devices. The automotive sector is growing at around 9% CAGR, and this is possibly driven by the focus on electric vehicles, ADAS or advanced driver assisted systems, and infotainment systems. The automotive industry is expected to spend $540 billion per year by 2030. The second biggest sector is the software research and development, which is also expected to grow and spend around $500 billion by 2030. And the third biggest sector is the healthcare industry. This industry grew exponentially during and post the pandemic. This sector will spend $620 billion in R&D by 2030, while the automotive, software, and medical devices sectors spend the most. Other sectors like telecom, semiconductors are also expected to see high growth rates at around 11 to 12% year over year in the next few years. Importantly, the telecom industry is set for expansion because it serves as the fundamental digital infrastructure. Several supporting applications in the future, such as IIoT or the Industrial Internet of Things or connected vehicles, depend upon the innovation in telecom. Their growth depends on improvement in network coverage, edge computing, and resilient connectivity. Telecom sector is predicted to be spending around $160 billion by 2030. The other sector that has a high growth rate is the semiconductor R&D. This sector currently grows at 10% year over year and is expected to be spending nearly $300 billion by 2030. The growth of this sector is directly related to growing demands for sectors such as automotive and telecom. As end consumers want better products, the semiconductors that go into these products also need to get better. Thus, there is a big demand in this industry as well. If you are someone who's wondering how all these big numbers around the ER&D spends correlate to the initial question about graduates getting the right job and being paid well, you're thinking right. How does all this relate to an engineer? What are the opportunities available to a mechanical, civil, and electrical and electronics engineers in India? Well, the answer boils down to 5 smaller questions about the engineering R&D spend across the globe. If you think about it, the first question is, what are the subdomains in each of these ER&D sectors that see the most development? Second, which countries lead the ER&D space? Which are the countries where the spend is highest in engineering research and development? The third question is, how much of this R&D spend is made in-house and how much is outsourced? The fourth question is, how much of this outsourced comes to India and how is it growing? And the most important question is the fifth one. What skills are these companies looking for from Indian engineers? We'll take up the first question, which is, what are the other subdomains in these ER&D sectors that are growing in this video, and the next 4 in the second part of this episode. As said in the beginning of this video, there are 9 sectors, and we will look into all these 9 sectors and the skills required and the opportunities available in these 9 sectors. The first sector that sees the most development is aerospace and defense. The current engineering R&D spend is $50 billion USD per year. And this spending is expected to grow at 8% year over year, reaching to $120 billion by 2030. So what are they spending the money on? Well, here are the top 5 areas of focus for the big aerospace and defense companies. Companies are looking at shifting to more fuel-efficient aircraft, such as sustainable aviation and electric propulsion. They want to tackle the concerns of cybersecurity and also increase the usage of automation. More importantly, they want to leverage additive manufacturing for lighter and more stable aircraft. And something interesting is they are spending their money on development of hypersonic flight and space travel. In addition to all of this, there is R&D going in survey drones and autonomous flight. So if you're an engineer who is curious about aerospace, and if you're someone who is looking at picking up a job in the aerospace and defense industry, you should think about focusing on the 5 research areas that we mentioned above. The second sector we are going to see is the automotive sector. This is one of the biggest ER&D spend sectors, and the sector ER&D spend is going to reach $540 billion by 2030. The growth of this sector is driven by electrification and electric vehicles. In addition to that, connected mobility and in-vehicle software priorities is driving this R&D spend in the automotive sectors. Let's look at the top 5 areas of focus for the automotive sectors. As you can guess, electrification and electric vehicles is the major spend. Autonomous and connected vehicles, primarily how can the car ride by itself, is what the research is going on. Vehicle design innovations. You might have seen Tesla Cybertruck. There are new designs that are being innovated. Enhanced vehicle safety and ADAS, Advanced Driver Assistance System, is a key focus area as well. If you're looking at a career in the automotive industry, these are the areas that require skilled engineers, right? So do focus on these areas. The third industry that we are looking at is consumer electronics. The ER&D spend is expected to reach $400 billion by 2030. This sector alone is growing at 8% CAGR, that is 8% year over year. The growth of this sector will be fueled by the focus on foldable and flexible display technologies, quantum computing in consumer electronics, the integration of AI and voice assistants in your devices, wearable health and fitness technologies. You might have seen already a lot of these technologies come in, but there is a lot of innovation that's going on. House automation and smart appliances, augmented and virtual reality experiences. These are some of the focus areas where R&D spends are being put in by a lot of big Indian engineering companies. If you are a EEE major or an embedded engineer, the consumer electronics sector has a lot of opportunities in these areas. The next sector we will look at is the energy utilities, oil and gas sector. The increased focus on green technologies and digitization is expected to boost the business ER&D spending to $220 billion by 2030. In the coming years, the growth rate is predicted to be around 8 to 10% year over year. The top ER&D priorities in the oil and gas sector are decarbonization, CCUS or commonly called as carbon capture, usage and storage technologies, energy efficiency and transition to renewable sources, energy storage breakthroughs, how do they store energy, and electric vehicle charging infrastructure. These are some of the focus areas for the oil and gas industry. If you're someone who's considering a career in the energy and oil sectors, these are specializations that you can consider. These are all in demand after all. The next sector that we want to look at is the healthcare and medical devices sector. As mentioned earlier in the video, this sector spends a lot on R&D, focusing on AI in medical devices and diagnostics, telemedicine and remote patient monitoring, AI and machine learning in medical diagnostics, robots in surgery and medical procedures, wearable health tech and fitness trackers, virtual reality for training and rehabilitation. The healthcare and the medical device sectors prove that engineers are truly necessary everywhere. Consider specialization in one of these areas for a future-proof career in this sector. In the industrial and the construction sector, the ER&D spending is driven by a focus on advances in data-backed operations and digitization to improve efficiency and product quality. The focus areas will result in ER&D spending of $280 billion by 2030. The top 5 focus areas in this sector are renewable energy integration, real-time AI embraced industrial analytics for efficiency, important resource utilization and predictive maintenance, robotics and automation in manufacturing, smart factories and digital twins, industrial IoT and Industry 4.0. The industrial and construction sector provides a lot of opportunities to mechanical, civil engineers to work on projects with a huge impact. If you are considering a career in this sector, work smart, upskill and research along the 5 areas of focus. The next sector that is growing at 10% year on year is the semiconductor sector. This sector gained momentum majorly because of the ambitions in automotive, aerospace, medical devices and pretty much all other sectors. This sector reportedly has one of the highest growth rates among all the others, with an estimated ER&D spending of almost $290 billion by 2030. The focus area in semiconductors are advanced packaging and chip stacking, energy efficient and low power design semiconductors, semiconductors in quantum computing, and growth of Internet of Things and edge devices. The other one area that the semiconductor industry is focusing on is heterogeneous integration of chips. The semiconductor sector has an impact on almost every other sector today. And to make an impact in this sector, upskill and build a skill set in these 5 areas of focus. Software as a sector has been seeing continuous innovation over the last 2 decades and is going to progress forward in the next decade as well. The next goal for the software R&D is to leverage AI breakthroughs. This sector is growing at a rate of 13% year over year and is expected to spend $500 billion in ER&D by 2030. Here's where the sector currently directs its focus: AI-driven personalization and recommendation, cloud-driven applications and microservices, cybersecurity solutions, edge computing. These are some of the top trends in the software sector, and these focus areas that I mentioned provide tremendous opportunities for skilled engineers. As mentioned earlier, the telecommunication sector will be the digital infrastructure on which most ER&D will be built. Telecom is another high-growth sector, focusing on edge computing and cloud infrastructure, network such as 5G, 6G network deployment, Internet of Things connectivity and devices, cybersecurity and satellite internet. The annual spend by 2030 in telecom industry is projected to reach 160 billion US dollars. To build a career in telecommunication, upskill and research along the 5 areas of focus. All these statistics show that there is a lot of spending with engineering R&D, and a significant portion of this spending will be on people. The focus areas from each sector tells us what skills the industry is looking for. Another key takeaway from the BCG and nasscom report is that the industry is primarily looking for mechanical, electrical and embedded engineers. To be more specific, every engineering stream has a few sub-skills that are in demand today. For mechanical engineering, the most important skills are mechanics, materials engineering, prototyping, computer-led analysis and 3D CAD modeling. In embedded and electrical engineering, the sub-skills are embedded systems, verification and validation, microcontroller-based systems, electrical circuit design, analog, digital, mixed signal circuit design, and VLSI. In addition to these core skills, it is important to at least know one programming language like Python, C, C++ or Java. While these are still broad skill sets, the goal of this episode is to expose you to the opportunities present in the ER&D industry. If you are interested in understanding how much of the ER&D spend is coming to India, what companies end up hiring, and what type of work will be available, stay tuned to the next episode. While there is so much happening in so many different sectors, the lack of exposure to this type of information is what makes people make wrong career decisions and not take up engineering even when they like it. So if you found this video helpful, do share it with fellow engineers. Stay tuned for our next video. You can also check the description to get the link to the next episode. If you are a mechanical, civil or electrical engineer and you want to know more about each of these sectors and their focus areas, do comment your questions below. I'll be happy to answer each of them personally. Do show some love by hitting the like and share button and subscribe to our YouTube channel. You will make us happy and YouTube even happier.